Hello everyone, today we are going to discuss the magnetic field of the earth, and after this video you should be able to explain the cause of the earth's magnetic field, define the different components of earth's magnetic field, and derive the relationship between different components of earth's magnetic field. Before starting, let's see some facts about the earth's magnetic field. The range of the magnetic field of the earth is about 60,000 kilometers. And the strength of the magnetic field of the earth is very weak as compared to a bar magnet. It is 1000 times weaker than the magnetic field of a bar magnet. Though the magnetic field is very weak, but it protects us from the harmful solar wind. Without the magnetic field, life on the earth is not possible, and the magnetic compass works due to the magnetic field of the earth. And this picture is the picture of northern light. We call it aurora borealis, and this happens due to the interaction between solar wind and the earth's magnetic field. Suppose I have a freely suspended bar magnet, and suppose I want to rotate this. In order to do that, I'll bring a big bar magnet near to it, and it will rotate because of the attraction between north and the south. But when we suspend a magnet freely on the earth, it also shows the particular direction. Freely suspended magnet on the earth rotates due to the magnetic field of the earth. So we can assume the earth is having a big bar magnet inside. The direction in which north pole points is called north pole of the earth, and the point towards which the south pole points is called the south pole of the earth. And this north and this south is geographical north and south of the earth. As we can see, north pole is getting attracted towards the north pole of the earth, so we should have magnetic south at the north pole, because south pole attracts north pole. Similarly, at south pole we should have north pole of the magnet, because the south pole is getting attracted towards the south. The geographical north and magnetic south, they are in one side, and geographic south and magnetic north is in another side. But the geographic north and the magnetic south, they do not coincide with each other. So geographic north is present somewhere out here, and magnetic south is at somewhere out here. Along the line joining north south, the earth rotates, and we can call it axis of rotation. And the axis of the magnet of the earth is not coinciding with the axis of rotation. So there is angle between axis of rotation and the magnetic axis of the earth, and that angle is 11 degree. Towards the north pole we have magnetic south, and towards the geographic south we have magnetic north. Now, cause of the earth's magnetic field. We know a current carrying loop can produce north pole and south pole. In the picture you can see the current carrying loop, and down is the south pole, and up out here is the north pole. So we need a current carrying loop to produce north pole and south pole. So inside the earth there is a solid core, and outside the core there is liquid lava revolving around the earth, and in the lava there are many charged particles and ions, and they are rotating in a circular path, producing the electric current in a circular path. And the current moving in a circular path produces two poles, north pole and south pole. So this is the main reason behind the magnetic field of the earth. Now we'll see some facts about the magnetic field of the earth. So earth is a natural magnet, and its magnetic field is present in everywhere on the earth, and we can assume there is a bar magnet inside the earth, but in reality its magnetic field is produced by the moving charges inside the earth. So magnetic north is towards the geographical south, and magnetic south is present near to the geographical north. And the magnitude of the magnetic field of the earth is 10 to the power minus 4 Tesla. Tesla is the unit of magnetic field, and 10 to the power minus 4 Tesla is equal to 1 Gauss. So we can say the magnetic field of the earth is 1 Gauss. And the axis of the dipole, this is the axis of the dipole, makes the angle 11 degree with the axis of rotation. So magnetic axis and axis of rotation is not same. Experimental evidence to prove the magnetism of the earth. When we suspend a magnet freely on the earth, it points towards the particular direction, which is indicating there is a magnetic field on the earth. If you bury a iron bar inside the earth for long time, it will also get magnetized due to the magnetic field of the earth. And the existence of neutral point. So if you keep a bar magnet, you will find a point where there is no magnetic field. So this happens due to the magnetic field of the earth, because out here you can see the magnetic field due to the bar magnet is in downward direction. So at this point it should not vanish, but because of the magnetic field of the earth, which is going in upward direction, will cancel each other, and at this point we will get the magnetic field to be 0. The presence of neutral point also proves the existence of magnetic field of the earth. So now we will discuss some of the terms related to the earth's magnetic field. So in this picture you can see this is the line joining geographical north and the geographical south of the earth, and this is the line joining magnetic south and magnetic north of the earth. So the first term is geographical axis. So geographical axis is the line joining geographical north and the geographical south of the geographical axis is also called the axis of rotation of the earth. So earth rotates through this axis, and the line joining magnetic south and the magnetic north is called magnetic axis. And geographical equator is the largest circle on the surface of the earth, which is perpendicular to the geographical axis. So you can see this circle is the largest circle, and this is perpendicular to the axis of rotation also. If you draw the circles out here, it will not be the greatest circle, so it has to be the greatest circle. So similarly, magnetic equator is the largest circle on the surface of the earth, which is perpendicular to this magnetic axis. So at any place, the geographical meridian is a plane passing through geographical north and geographical south of the earth. And if you want to know the magnetic meridian at that place, you have to keep a magnetic compass, and the plane passing through the axis of magnetic compass is called magnetic meridian at that place. So out here you can see, so this is the north pole and this is the south pole. So this plane is called geographical meridian, and if you keep the compass at this place, then this plane is along the axis of the compass. So this plane is called magnetic meridian. So different places we have different geographical and magnetic meridian. So out here you can see these blue lines are the geographic meridian, but these red lines are the magnetic meridian. So if you keep a compass at this place, it will align along the red line. Elements of Earth's magnetic are the three elements using which we can completely describe the Earth's magnetic field at any place on the surface of the Earth. So they are magnetic declination, angle of dip, or horizontal component of Earth's magnetic field. So let's talk about the magnetic declination. Suppose these 2 points are geographical north and geographical south of the Earth. So the plane passing through these 2 points is called geographical meridian. So this dotted line is the geographical meridian. So suppose this is the magnetic south. So we all know magnetic south and north, they do not coincide with each other, so they are at some distance. If you keep a magnetic compass out here, it will deflect towards the magnetic south. So the plane passing through the axis of the compass is called magnetic meridian, and the angle between these two is called magnetic declination. So magnetic declination is angle between magnetic meridian and geographical meridian at a place. So similarly, if you keep the compass out here, it will also point towards the magnetic south. So and the line passing through this is called magnetic meridian, and this angle is called magnetic declination. So as you can see, at different places we have different magnetic declination. So this is the magnetic declination at this point, and this is the magnetic declination at this point. So in this picture you can see at different places magnetic declinations are different. So if you consider this point, so the black line is the magnetic meridian, which is passing through the geographical north and geographical south, and this red line is the magnetic compass. So the line along the magnetic compass is the magnetic meridian. So this angle is the angle of declination. So if you consider this point, the angle of declination is small, and out here the magnetic meridian and geographical meridian is in same line. So out here angle of declination is 0. Out here it is changing, out here also it's more. So at different places we have different angle of declination. So angle of declination is the angle between magnetic meridian and the geographical meridian. Along the line of the compass is the magnetic meridian, and the line along north pole and south pole of the earth is the geographical meridian, and the angle is angle of declination, and it is denoted by alpha. And it is also called the deviation of the compass from the true north. So this is the actual north of the earth, but compass is showing magnetic south. The deviation of the compass from the true north is also called the magnetic declination. And the reason we are having the magnetic declination is that the geographical north and the magnetic south, they do not coincide with each other. So in order to know the magnetic declination at a place, we have to keep a compass, and whatever angle the compass make with the line joining the geographical north and the geographical south of the earth is magnetic declination. If magnetic declination is small, that means the magnetic compass is showing the true north, and if the angle of declination is large, magnetic compass is not showing the north pole of the earth. So we cannot use the magnetic compass in everywhere on the earth. In some of the places the compass works properly because the declination is small. So in India the magnetic declination is small, so we can use the magnetic compass in India. So if you consider this place, the compass will show the north towards this position, but the actual north is at this position, so there will be error in the compass. This is the map of the earth showing the different angle of declination at different places. So out here you can see there is no declination, so but if you go down out here, so we have the large declination.